All right, so section 2.3 we're talking about calculators we're going to be using to find estimates of our trig function values. So we need to make sure, we've talked about this before, you have to be in degrees. The mode has to be set in degrees. If you have your mode in radians or something else, you're going to get everything wrong. So let's take a second and just make sure that we are in fact in degree mode. So we're all using the same scientific calculator, so you should be able to look right there and it should say DEG. So if it does not say DEG, you just hit the mode button and then the very first option, DEG, RAD, GRAD, you want to make sure you're on DEG. Okay? Once you set it, now you're in it. And it won't change until someone actually goes in and changes it. Okay? So just always check that, because remember, other kids are using these calculators. You don't know what they're doing. They might change it on you. You don't want to fail a quiz because you forgot to check. All right. So I just mentioned to you that the calculator can do degrees, minutes, seconds, and you don't have to. So let's just try and let's say we wanted to add two numbers together that were in degrees, minutes, seconds. So let's say we did, just make up one here. Say we wanted to do 15 degrees 2 minutes, and we wanted to subtract from that, oh, I don't know, 9 degrees 45 minutes. Something like that. So remember how annoying that was. I didn't have enough here, so I'd have to borrow, and I'd have to change this, and it was a whole thing. Now, Mr. Calculator will do it for me. So, we want to enter in 15 degrees. So go ahead and type in 15. And then, let's see if I remember how to do it on these calculators. Do you see a button? I thought there was one that said degree on it. Or maybe do I have to go to, see, I usually do it on the graphing calculator. Is it this? Nope. Maybe I should have had you grab the other one. I swear it does it. Where is it? Is it there? Oh yeah, there it is. Okay. Angle. See, it says angle right there above the PRB button. See it in green? So if we want to access stuff to do with an angle, we're going to hit second and then that PRB button to access that angle menu. Okay, and take a look at our options. Look, the first thing is a little degree symbol. The second, minutes and seconds. So I want 15 degrees, so go ahead and choose choice 1. Oh, 15 degrees. So does yours look like that? And now I wanted 2 minutes, so then I'll do 2, and then I'll choose the minutes option, choice 2. And then I can just write from here, minus 9 degrees, 45 minutes. So I can put it all in there at once, and then we hit enter. Now, it's giving it to me as a decimal, but I believe you can turn it into degrees. Let's see if I remember how to do that. Yes, okay, good. So you have your answer. If you hit that second angle again and you scroll all the way down to this DMS, that stands for degrees, minutes, seconds. So what that will do is take your answer and put it into degrees, minutes, seconds for you. So if you just hit enter, mine's probably gonna mess up now because I already did it, and then hit enter again. Oh no, it didn't. It gives you your answer. Degrees, minutes, seconds. Yes. So you didn't have to do it by hand. Try another? Okay. let's say we did 100 degrees, 19 minutes, 3 seconds. Let's go to seconds now, and let's add to it 5 degrees, 50 minutes, 9 seconds. I don't know. Try and add those two together. And then see if you can get your decimal answer to change to degrees, minutes, seconds. So this is what I got. Did you get the same thing? All right, cool. So now we know that the calculators can do that. If you happen to be using a graphing calculator, it's kind of the same idea. You would still type in 100, and then this one, that's funny. It also has an angle button right there. So I would just access that angle menu, and then I have basically the same things. Degrees, minutes. Oh, don't I have seconds on this one? Oh, can you only do degrees, minutes? Well, that's weird. I don't know what that thing is in number 3. Is that the way that this calculator shows seconds? I don't know. I'll have to ask. I don't think that's ever come up. But then I also have that same option to change it into degrees, minutes, seconds if I have decimal. Okay. So that's convenient. If we look at our note sheet under example 1, the very first thing I'm supposed to do is find sine of 49 degrees 12 minutes. Well, now that I know how to type in degrees and minutes, that should be relatively easy. So I just go ahead and hit sine 49 degrees and then 12 minutes. Oh. I'm asked for the approximate values, so I can go ahead and round this. Anytime we are doing trig functions, we usually go out 4 decimal places. Okay, so that's standard. So let's go out 4 decimal places. So for A, I would call that 0.75 what? 70. Right? So that would be your 4 decimal places if you rounded this correctly, 4 decimal places. Okay, now secant. How do I access secant again? Exactly, 1 divided by, and then I want the cosine of 97.977. There we go, round that 4 decimal places. So I get negative 7.2059, right? If you're going to round correctly 4 decimal places. Now, C is interesting. You can do this all in the calculator if you're very careful, but it might be better if you just kind of think about it for a minute. So we want 1 over the cotangent of this. Yeah, right? Because think about forget about the decimal for the angle here for a second. Remember that cotangent is just the reciprocal of tangent, right? So if I want 1 over, if I want the reciprocal of this side, 1 over that, don't I just want the reciprocal of this side? So this whole thing is really the same thing as just tangent of 51.4283. Does that make sense? Maybe? Because cotangent is 1 over tangent. So if you do 1 divided by 1 over tangent, it's just tangent. The calculator can handle all that, but there would be a kind of a typing nightmare. So, but once I realized, oh, it's just the same thing as tangent of 51.4283, that wasn't so bad. And I get round to 4 decimal places, 1.2539. Another cool thing about using the calculator is when I hit something like D, I don't have to worry about finding a coterminal angle. You can, but why bother? The calculator can handle negative angles, can handle huge angles. I don't have to spend the time finding the coterminal angle if I don't have to. So I just pop it in as it is. Sine of negative 246. Thank you. 0.9135. Okay, so I don't know how much you remember from geometry, but let's see if you remembered what to do with something like this before we move on to the next spot. Say you had a right triangle, right? And you knew, I told you that this was, who cares, this is 5, this is 3, and I wanted you to find the measure of this angle. Do you remember doing that? Maybe, hopefully. Okay, so you did use trig, you used SOHCAHTOA, remember, for in geometry, you used it. So, what ratio would I be using, sine, cosine, or tangent? If I'm trying to find this angle, and I have these two sides, cosine, right? This is the angle I'm trying to find, and in relation to this angle, I have the adjacent side and the hypotenuse. So adjacent and hypotenuse, according to SOHCAHTOA, that means I'm using cosine, right? Yeah? Okay. So cosine of my mystery angle is 3/5. You solved this for theta. You found the angle back in the day. I don't know if you remember how you did it. Does anybody remember? You got this far on your last quiz. I asked you for like the sine, cosine, tangent of angle C or whatever it was, and you gave me the fractions. But now I want you to actually find what that angle is. Think back. What did you do? Well, this is just a decimal, right? 3/5 is just some decimal. What is the decimal that 3/5 is? 3/5 is 0.6, right? If it was some weird one that I didn't know, I would just do on my calculator 3 divided by 6 and see what comes out. All right, so you have some options. Remember, we had trig tables, so you could look at the trig table for who has a cosine of 0.6. So you could do that. But of course, we have Mr. Calculator. He can tell me too. But does anybody recall how you had to type it in the calculator? There was one special thing that you had to do.
Was it second?
Yes, yes, yes. If you are trying to find the measure of the angle, I don't know what the angle is, I have to use what's called inverse cosine, or inverse sine, or inverse tangent, whichever one I'm doing. Okay? And all that is, it looks like, if you look on your note sheet, okay, this is the inverse of cosine. So we write it as cosine to the -1 power, but we say it out loud as inverse cosine. So on my calculator to do it, I just hit second cosine. If you look right above the button for sine, cosine, tangent, see how it has them to the -1 power? See that? So if I don't know the measure of the angle, I hit second and then sine, cosine, or tangent. And then in this case, it'd be 0.6. And then I go ahead and hit enter. That means that angle right there has to be 53.13 degrees. How about that? So usually we round angles to the nearest whole angle. You just look and make sure that whatever worksheet or test or quiz, if it says, usually we just round to the nearest whole. Does that make sense? So if you look at the very bottom here, well, we are looking for who has a sign of this decimal. Who has a secant of this decimal and who has a cosine of this. I guess that's not really a decimal, but that's okay. So let's try with letter A. So I'm going to, what do I push on my calculator? Second sign, and then I type in that decimal. It's a good habit to get into to close your parenthesis. It won't matter if you leave it off, but it's just a good habit. Oh, so how about that? That means that that angle must have been 75.4. If you round to the nearest whole, then 75 degrees. So a 75-degree angle would have a sine approximately equal to that. Does that make sense? Okay. Now, B, I don't have a secant button, so I can't just hit second secant. Secant, remember, is 1 over cosine, right? So think about what this is really saying. This is the same thing as saying 1 over cosine of my angle is approximately this crazy decimal. So here's what I can do. I want just cosine of this, not 1 over cosine. So can't you take the reciprocal of both sides? Yes, so cosine of this would be equal to 1 over all this. So cosine of that equals 1 over that crazy decimal. And now I can put that in the calculator, I just have to be careful. What do I hit first? Yeah, I do need to do second cosine. So watch how we type this in. Second cosine, and now I need to do 1 divided by that crazy decimal. 1 divided by all that business. 1.0545829. Close your parenthesis, and let's hit enter. All right. So approximately, if I'm rounding to the nearest whole degree, that would be a 19-degree angle, would have a secant equal to that crazy number. Is that all right? Okay, and then the last one, who's going to have a cosine of 2? What should I hit? Second cosine, pop in a 2. What happened? Why did it break? Did yours break?
Yeah.
Why? Yeah, and that can't happen. Cosine, remember we had the ranges of possible values? Cosine can only ever be between -1 and +1. It's impossible to get a cosine of 2. Impossible. So this doesn't have an answer. There is no value of theta that has a cosine of 2. So, doesn't exist or not possible. Don't leave it blank, right? Because blank means you don't know. And you do know. You know that there's not an answer. So, no solution or whatever you want to put. Just indicate to me that that's impossible. I think before we start this next part, maybe I'll just have you practice with what we've talked about so far, because the next part's going to take a little while. and we don't have enough time before lunch. So let's stop this here.